What if you could build a fully insulated wall in hours, not days, and make it strong enough for high winds and earthquakes? That's the promise of the Hobbs vertical ICF-Wall system, a formwork method that looks deceptively lightweight, but delivers serious performance. At first glance, the panels, made from plastic and expanded polystyrene foam, seem almost toy-like, but the system is engineered for resilience in high wind regions and seismic zones, giving it a place in both residential and commercial builds. One of its biggest advantages is speed. The Hobbs system can reduce assembly time by up to 50% compared to traditional methods. It also uses up to 40% less concrete, thanks to its vertical design and efficient internal bracing, a significant cost and weight savings for large projects. For projects on tight deadlines, there's a stucco-ready version of the system. In this configuration, the studs are integrated within the foam panel, allowing builders to apply stucco directly without additional sheathing or mesh. This streamlines finishing and cuts down on labor. Despite its lightweight components, the Hobbs vertical ICF provides the structural integrity and thermal insulation needed for modern building codes. It's a system that combines energy efficiency, speed, and resilience in one package. Coming up, a foldable concrete form that ships flat, sets up fast, and changes how formwork is done on tight urban sites. A concrete form that folds flat for shipping, sets up in minutes, and slashes material use. That's the innovation behind un-foldable form, developed by the Zurich University of Applied Sciences. It's a breakthrough not just for builders, but for sustainability. This formwork system can reduce concrete use by up to 60% and steel reinforcement by as much as 90% when constructing reinforced concrete slabs. The secret lies in its geometry and material efficiency. Instead of traditional rigid molds, un-foldable form uses thin, flexible plywood strips that are hinged together. These strips unfold like a fan, creating a precisely curved mold that supports the concrete in just the right places to maintain strength while using far less material. At first glance, it might seem too delicate for serious work, but the prototype weighs only 24 kilograms or 53 pounds, yet it can support up to 1 metric ton or 2,205 pounds of concrete once in place. Even more impressive, the cost to build this prototype was up to $714 in materials, making it accessible for pilot projects and small-scale adoption, with massive savings possible at scale. By shipping flat and assembling quickly, un-foldable form reduces transport emissions, speeds up setup time, and opens the door to more environmentally conscious construction practices. An anchor system that grips concrete so securely, you might rethink how you attach heavy loads to structural walls. Stay tuned to see. Need to attach heavy loads to concrete, even underwater? That's where the Rawlplug R-HAC-V chemical anchor system comes in, providing a secure, high-strength hold in situations where standard expansion anchors fall short. Unlike mechanical anchors that grip only at certain points, chemical anchors bond along the full length of the hull, distributing the load evenly. This makes them ideal for securing rebar, threaded rods, and structural components in both new construction and retrofits. One major advantage, they handle imperfect or oversized holes with ease. The chemical compound fills gaps, locking components in place with a strength that rivals cast-in-place connections. Certain formulations are even rated for underwater installation, making them perfect for marine, bridge, or flood defense projects. Installation is straightforward. For capsule-type anchors, simply drop the capsule into the drilled hole, then drive the threaded rod or rebar through with a hammer. As the capsule breaks, it releases and mixes the resin, creating a rock-solid bond. The shattered capsule fragments remain in the mix, further reinforcing the joint. From small timber frames to large reinforced concrete structures, the Rawlplug R-HAC-V is a versatile solution for high-stress, high-reliability connections. Drywall so tough it can handle daily abuse in high-traffic spaces and still look new? Keep watching to see how. Imagine drywall that can withstand the daily punishment of a busy school hallway or a hospital corridor without constant repairs. That's the RIGIPS Riduro panel system. High-performance gypsum boards designed for durability and safety in demanding environments. The secret lies in its impact-resistant core and innovative edge protection, which prevent chipping and edge damage during both installation and service life. These panels maintain a clean, professional appearance even after years of hard use. Safety is another strength. Riduro panels provide 90 minutes of fire resistance, meeting strict safety standards for public buildings. They also perform well in high moisture areas, such as kitchens, bathrooms, and utility rooms, where standard drywall would deteriorate. Each panel is manufactured to a standard 3-meter or 9.84-foot height, but custom orders are available for projects requiring different dimensions, a plus for architects looking to minimize seams. Installation is similar to standard drywall, so there's no steep learning curve for crews. The added durability comes without sacrificing workability, allowing for easy cutting, shaping, and finishing. From hospitals and schools to commercial kitchens and public facilities, RIGIPS Riduro offers a long-term, low-maintenance wall solution that balances strength, safety, and design flexibility. Coming up, a spray-on concrete so strong and so fast, it can stabilize collapsing structures in minutes. Strama Panels are an innovative exterior finishing system designed specifically for buildings constructed with polystyrene or minimal wool insulation blocks. Unlike traditional wet render systems that require curing time, Strama uses a completely dry installation process, allowing projects to move forward regardless of weather conditions. The panels are primarily composed of a lightweight yet durable aluminum core, finished with a real wood veneer top layer. This construction offers the natural warmth and texture of timber, while maintaining the structural stability and low-maintenance benefits of metal. Because the veneer is factory treated, it is resistant to UV fading, moisture ingress, and insect damage. Installation is remarkably straightforward. Panels are supplied pre-cut to size and can be mounted directly to the substrate using concealed fastening systems. This not only speeds up assembly, but also creates a seamless, screw-free appearance. The simplicity of the process is such that the manufacturer's full installation tutorial lasts just 38 seconds, a testament to its efficiency. Design flexibility is a key strength. Strama panels are available in over 100 finish options, ranging from classic oak to modern charred wood effects. This allows architects and builders to match virtually any design vision without sacrificing durability. For retrofits, Strama can be mounted over existing facades with minimal preparation, instantly upgrading a building's appearance and thermal performance. Maintenance is as easy as periodic cleaning with mild soap and water, eliminating the need for costly refinishing. Solar panels so thin and flexible, you can install them almost anywhere. No rigid frames required. Stay tuned to see. TechCrete Fast is a specialized dry mix shotcrete formulation designed for rapid application and exceptional structural performance. This high-strength material is heavily reinforced with alkali-resistant glass fibers, providing enhanced tensile and flexural strength while maintaining excellent adhesion to a wide range of substrates. The formulation achieves a comprehensive strength of 75 megapascals, or 10,877 pounds per square inch, making it suitable for high-load, high-impact applications. It bonds strongly to rock, concrete, masonry, and steel, ensuring a stable surface even in challenging environments. For projects requiring additional reinforcement, steel mesh or polymer grids can be integrated into the sprayed layer to further increase performance. One of TechCrete Fast's greatest advantages is its rapid strength gain in emergency stabilization scenarios, such as after rock falls in mines, spalling in tunnels, or structural deterioration in bridges. It can be applied in thick layers in a single pass, quickly hardening to restore safety This allows crews to reopen critical infrastructure or continue mining operations without prolonged downtime. The dry application method also means reduced rebound and wastage compared to traditional wet mix shotcrete. Application involves loading the dry material into a shotcrete machine, adding water at the nozzle and spraying directly onto the prepared surface. Its superior pumpability and fiber distribution ensure an even, durable coating with minimal sagging. Techcrete Fast has proven reliability in mining, civil engineering, slope stabilization, and even military fortification projects. Anywhere rapid, strong, and lasting structural support is required. Sun flare panels represent a leap forward in photovoltaic technology after 16 years of research. Unlike rigid glass modules, these ultra-thin, lightweight panels are built on a flexible stainless steel substrate. The result is a solar module that is 65% thinner, 86% lighter, and 10% more efficient than many conventional panels, while maintaining durability in real-world conditions. One of their standout features is installation versatility. Panels can be mounted on rooftops, facades, or even curved vehicle bodies without the need for heavy racking systems. Instead, they can be secured with industrial-grade double-sided adhesive tape, drastically reducing installation time and avoiding penetrations that could compromise waterproofing. A standard Sunflare Flex 60 panel measures 1 meter by 1.65 meters, or 3.28 feet by 5.41 feet, and produces up to 180 watts of power. The technology was showcased on a Tesla Cybertruck, where an array generated 1.5 kilowatts per hour in full sunlight, enough to offset significant auxiliary power loads. Sun flare panels are also highly resistant to microcracking, a common issue in traditional silicon modules, which helps maintain long-term efficiency. Their frameless, glass-free design reduces weight strain on structures, opening possibilities for retrofitting older buildings that can't support heavy solar arrays. Installation involves cleaning the mounting surface, applying adhesive pads or strips, and connecting the integrated leads to an inverter or battery system. The panel's flexibility makes them especially valuable for applications where conventional modules can't fit, bringing solar to entirely new markets. Shock Isocorp is a specialized thermal insulation system engineered to prevent heat loss at critical structural connections, such as balconies, parapets, canopies, and stair landings. Without a thermal break, these junctions act as thermal bridges, allowing heat to escape in winter and enter in summer. This not only raises energy costs, but also increases the risk of condensation, mold growth, and freeze-thaw damage. The Isocorp unit combines high-density insulating materials with stainless steel reinforced bars, ensuring structural load transfer while dramatically reducing thermal conductivity. It is designed for concrete to concrete, steel to steel, and mixed material connections, making it suitable for a wide range of building types, from residential towers to commercial complexes. Installation is straightforward. Units are placed between the building's structural slab and the projecting element during the reinforced stage before the concrete pour. Pre-drilled alignment guides ensure correct placement, and the system can be integrated seamlessly with standard reinforcement layouts. Because the installation is built into the connection, there's no need for additional cladding or external wraps to meet energy code requirements. It can also be retrofitted into existing designs during renovation. It's a solution that works equally well for new construction and upgrades to older buildings. This integration not only improves building envelope performance, but also extends structural life by reducing moisture ingress and corrosion risks. Certified for high-load applications and meets stringent passive house and low-energy building standards. VOG Screen Vision 2.0 is a cavity screen system designed to improve energy efficiency in greenhouses by separating the upper and lower air zones. When deployed, it reduces the volume of air that needs heating during cold nights or after sunset, significantly lowering energy costs. Available in 3 drive types: push-pull, pull wire, and semi-push-pull. The system can be tailored to fit different greenhouse layouts. Each component is engineered for precision, minimizing blousing, the unwanted sagging of the screen, and ensuring a tight, consistent seal. The screen fabric allows for optimal light diffusion, so plants still receive sufficient daylight during colder periods. At night, the screen helps retain heat, while during the day it can be partially retracted to fine-tune temperature and humidity levels. This makes it ideal for growers who need year-round climate control without sacrificing plant growth quality. Installation is straightforward, and the modular drive systems make maintenance easier, with fewer moving parts exposed to humidity and temperature fluctuations. By integrating Bulk Screen Vision 2.0 into their operations, growers can expect better crop yields, reduced energy bills, and more precise control over greenhouse conditions. Whether in large commercial operations or specialized research greenhouses, this system offers a long-term return on investment through energy savings and improved plant health. The WoodTech Element Bodish is a modular assembly table engineered for the efficient production of timber frame elements. Each standard module measures 1.5 by 3 meters or 4.92 by 9.84 feet, but multiple modules can be joined to create a work surface tailored to your workshop size and budget. A standout feature is its precision, engineered whole grid, allowing the quick positioning of jigs, clamps, and other assembly aids. This ensures that wall and frame components can be assembled accurately, even by a single operator. The yellow grid lines are marked with metric scales, giving immediate reference points for cutting, drilling, or fastening. Manufactured by using CNC machining, the table surfaces are perfectly flat and smooth. This high degree of accuracy makes it easier to detect even small misalignments in a frame before it moves on to the next stage of production. The robust steel frame ensures long-term stability under heavy workloads, while the modular design makes it simple to expand or reconfigure your workspace as production demands change. By combining strength, precision, and flexibility, the WoodTech Element Bodish supports faster assembly without sacrificing accuracy, making it a smart investment for both small workshops and large-scale timber frame manufacturers. Coming up, concrete panels that can literally grow, transmitting light through solid stone. The Oneida Superdust Deputy 4/5 Superdome Cyclone is designed to dramatically improve dust collection in woodworking and fabrication environments, acting as a pre-separator for single-stage dust collectors. It removes 99.99% of airborne dust particles before they reach your system's filter. Compatible with dust collectors rated for at least 10 cubic meters or 353 cubic feet per minute and up to 3 horsepower, the Superdust Deputy captures everything from fine sawdust to larger debris, like screws and wood chips. This not only improves air quality, but also prevents filter clogging, extending filter life and maintaining strong suction over time. The Cyclone's design channels incoming air into a rapid circular motion that forces heavier particles to drop into a collection bin, while allowing only clean air to pass through to the filter. Built from high-quality anti-static materials, it also reduces the risk of static buildup, a key safety feature in environments where fine dust can pose a fire hazard. Lightweight yet durable, the unit is compact enough to fit in small workshops while delivering performance that rivals much larger systems. Whether you're running a home workshop or a commercial fabrication space, the Superdust Deputy provides cleaner, safer, and more efficient dust management by keeping your equipment running at peak efficiency and your workspace free from harmful particles. It quickly pays for itself and reduces maintenance and downtime. Lucem takes ordinary concrete and gives it an extraordinary property, the ability to transmit light. This is achieved by embedding thousands of optical fibers into the mix, creating panels that can carry natural or artificial light from one side to the other without sacrificing structural integrity. Available in standard sizes, such as 120 by 65 by 3 centimeters or 47.2 by 25.6 by 1.18 inches. Lucem panels come in finishes like gray, anthracite, and ivory. They can be custom cut or shaped to suit unique architectural requirements. Despite their slender profile, they are robust enough for use in both interior and exterior applications. Designers have used Lucem for everything from partition walls to bar counters, reception desks, and even swimming pool dividers that respond to water movement with subtle changes in illumination. The effect is striking. Light patterns shift and ripple across the surface, adding a dynamic, almost living quality to the structure. Lucem can also be integrated into functional architectural elements, such as stair treads, signage, or facade panels, combining beauty and practicality. Its ability to bring light deep into a structure offers energy-saving potential in certain applications, reducing the need for artificial lighting. This material bridges engineering and art, appealing to architects seeking statement features and engineers who need durable, code-compliant materials. E-concrete is a unique construction material designed to strengthen marine and coastal infrastructure while actively enhancing local ecosystems. Developed through collaboration between engineers, urban planners, and marine biologists, it's used for applications such as seawalls, breakwaters, piers, and underwater mattresses. Unlike traditional concrete, which can inhabit marine life, e-concrete is formulated with environmentally friendly additives and has a surface texture engineered to encourage biodiversity. Its design incorporates grooves, cavities, and varied microtopography that provide shelter for fish, shellfish, and other organisms. Over time, these organisms contribute to natural reinforcement by depositing calcium carbonate and other substances that help protect and strengthen the structure. The concrete's durability is a major asset. It's been tested for long-term use in tropical waters, high salinity environments, and areas exposed to strong tidal forces. It can be cast into modular elements and large precast panels, allowing for rapid deployment in large-scale marine engineering projects. From an environmental perspective, e-concrete helps reduce habitat loss in urbanized coastlines. From a structural standpoint, it provides performance on par with or exceeding conventional marine-grade concrete. This dual benefit makes it particularly appealing for governments and developers aiming to meet sustainability targets while still protecting against storm surges and coastal erosion. By merging ecological science with structural engineering, e-concrete sets a new benchmark for resilient, environmentally responsible infrastructure. How to make concrete last decades longer, even in the harshest wastewater environments? Keep watching. SikaGuard 7000 CR is a high-performance protective coating designed to extend the life of concrete structures exposed to some of the harshest chemical and mechanical environments. It is particularly effective in sewer systems, wastewater treatment plants, and industrial facilities, where concrete faces constant abrasion, chemical exposure, and moisture. The coating forms a dense, durable membrane that resists biogenic sulfuric acid, a common cause of corrosion in sewer infrastructure. It also protects against abrasion caused by high-velocity water carrying sand and grit, which can erode untreated concrete surfaces over time. Application is straightforward and can be done with a roller or sprayer, making it ideal for large surface areas. Once cured, SikaGuard forms a seamless barrier that adheres tightly to the substrate, preventing water or chemicals from penetrating the concrete. This greatly reduces the risk of cracking, spalling, or structural degradation. The system can be applied to new structures to prevent damage from the start, or the existing infrastructure as part of the rehabilitation program. In both cases, the result is a significant extension of surface life, reduced maintenance cost, and improved safety in critical facilities. SikaGuard's proven resistance to aggressive chemicals makes it suitable for food processing plants, chemical manufacturing sites, and marine applications in addition to wastewater systems. It's a preventative measure that pays for itself many times over in reduced repair costs. XYM BIM is an advanced augmented reality inspection system designed to overlay a full building information model directly onto the real-world construction site using a headset or AR-compatible glasses. Inspectors and engineers can walk through a project and see digital plans aligned perfectly with the physical structure in real time. This allows instant identification of deviations, even down to a few millimeters. For example, in one project, a ventilation duct was found to extend 28 centimeters or 11 inches farther than designed, something that might have been missed. With manual measuring, XYZ BIM can also highlight small issues, such as a loose bolt or a misaligned fitting, before they cause costly delays. The system integrates seamlessly with major design software platforms like Autodesk Revit and Navisworks, so project data can be imported without additional conversion. This compatibility ensures that what you see in the field matches exactly what was modeled in the office. One of XYZ BIM's biggest advantages is efficiency. Inspectors no longer need to carry stacks of blueprints or consistently switch between paper drawings and site conditions. Instead, they can visually compare the as-built structure with the design model in real time, documenting discrepancies on the spot. The technology is particularly valuable in complex builds such as hospitals, airports, and large infrastructure projects, where precision and coordination are critical. By catching issues early, XYZ BIM helps reduce rework, saves costs, and improve project timelines. Wall partitions that can be installed in hours and reconfigured whenever you need. Stay tuned. Imagine installing a wall in minutes. No plastering, no sanding, no mess, and reusing it whenever your space needs to change. That's exactly what the Juno solid wall partition system delivers, making it a favorite in commercial spaces, offices, and even high-end residential builds. The secret lies in Juno's patented telescopic steel frame. This allows height adjustments to be made in seconds without cutting, drilling, or extra tools. Each wall segment is designed for a single-person installation, reducing labor costs and avoiding scheduling delays. Compared to traditional drywall, setup is 5 times faster, and you're left with a clean, finished surface immediately after assembly. Panels come in a variety of textures, colors, and finishes, from sleek laminate to acoustic fabric, letting designers match branding or decor instantly. Need to reconfigure an office layout? The wall simply disassembles and relocates. No demolition waste, no patch repairs. From a sustainability standpoint, Juno contributes to LEED certification by minimizing material waste and promoting reuse. Since the panels are precision-built, there's no need for disposable fillers or joint compounds. Whether you're fitting out a retail space overnight or reorganizing a workplace for new teams, Juno turns walls from static barriers into dynamic, reusable design elements. A brick slip cladding system that combines the heritage look of masonry with the speed of modern construction. This is now a reality. Keep watching to see it. For projects where the charm of real brick is essential, but the logistics of traditional masonry aren't practical, SureBrick offers a modern solution. This system uses precision-engineered aluminum or galvanized steel profiles to mechanically lock brick slips, thin slices of real brick, into place. Each slip can be up to 9 centimeters thick, or 3.54 inches, delivering the depth, texture, and shadow lines of solid brickwork without the structural load. Once the slips are in place, they're securely anchored, making the finished facade strong enough for timber frame construction and reinforced concrete skyscrapers alike. Installation is clean and fast. No mortar mixing, no extended curing times, and the profile ensure perfect alignment from course to course. Fire safety is also addressed. In its standard form, SureBrick is fireproof, providing peace of mind for high-rise applications. One of the lesser-known advantages is its role during early construction. Before the building envelope is complete, SureBrick can act as a temporary weather shield, protecting internal work from wind and rain. Architects benefit from flexibility too. SureBrick can be used to create curved walls, feature panels, and complex patterns that would be labor-intensive with traditional bricklaying. With its blend of authentic appearance, speed of assembly, and structural compatibility, SureBrick bridges the gap between old-world aesthetics and modern build efficiency. Cutting recesses into hardened concrete is messy, time-consuming, and often compromises structural integrity. Steckbox solves the problem before the pour begins, providing a ready-made cavity exactly where it's needed. This modular plastic formwork system is available in 36 standard sizes, from compact 15 by 15 centimeters or 5.9 by 5.9 inches up to 50 by 50 centimeters or 19.7 by 19.7 inches. Each unit is placed in the formwork before the concrete pour, and here's the efficiency boost. The box stays in place permanently. There's no stripping, chiseling, or rework after curing. Manufactured from a fire-resistant polymer that meets the EN 1363-1 standard, Stekbox is suitable for both residential and heavy-duty commercial builds. Because it's plastic, it can be easily modified with a hole saw or cutting tool to allow for plumbing runs, electrical conduits, HVAC ducts, or other service penetrations. The system's precision molded edges create clean recess lines, saving finish work and keeping trades on schedule. Multiple units can be positioned to form complex layouts. For example, access panels in utility corridors or custom niches for embedded lighting. By eliminating the labor involved in building and later removing temporary timber boxes, Stekbox helps contractors reduce both build time and waste, while delivering a more predictable, professional finish. When heavy infrastructure projects demand strength, flexibility, and speed, the Perry Alpha Kit is built to deliver. Designed for large-scale applications such as bridge piers, tunnel linings, and elevated roadway structures, this modular system combines the load capacity of heavy steel trusses with a design that can be assembled quickly without cranes. Instead of bolts, Alpha Kit uses high-strength locking pins. Not only are pins faster to install, a quick hammer strike secures them, but they also avoid the thread wear and jamming issues common with bolts on dusty, high-traffic sites. Individual components are light enough to be carried and pre-assembled by hand. Yet when locked together, they can create shoring towers and trusses spanning up to 28 meters or 91.9 feet. This makes it suitable for everything from temporary formwork supports to permanent bridge maintenance platforms. The steel elements are hot-dip galvanized, protecting them from corrosion in marine and high-humidity environments, and the entire system is reusable, making it cost-effective across multiple projects. Engineers appreciate its modularity. The same kit can be reconfigured to support different geometries, reducing storage space and equipment investment. On congested urban projects, where cranes are hard to position, crews can still build full-capacity support structures safely at ground level before lifting them into place. It's a rare combination: speed in setup, flexibility in design, and sheer load capacity. Coming up, a building system you can dismantle decades later, move across town, and rebuild from the same parts. The MPS Flex isn't just a structural frame, it's a shift in how we think about construction life cycles. Built from prefabricated steel and concrete composite beams, columns, and floor slabs, it's engineered for full disassembly when a building reaches the end of its service life. Instead of demolition, the structure is unbolted, components are inspected, and the same elements are reused in new projects. This means massive savings in raw materials, particularly in an industry that consumes 60% of the world's mineral, metal, and timber resources. Prefabrication also slashes on-site demands. The NPS Flex can reduce labor by up to 80% and cut build time by 40% thanks to precision manufacturing and modular connections. Floor slabs arrive ready to install with pre-formed service routes, so plumbing, HVAC, and electrical systems can be laid in with a minimal modification. Its flexibility extends beyond sustainability. Developers can reconfigure a building's layout years later without structural compromise, making it ideal for commercial spaces, sports arenas, and educational facilities where adaptability is key. Durability is also a priority. Steel frames are protected with anti-corrosion coatings, and concrete components are engineered for high compressive strength, meaning they can endure repeated assembly cycles without performance loss. By turning the end of life into ready for next life, NPS Flex pushes construction towards a true circular economy. The Hilti J-Bod isn't just a construction tool. It's a new type of worker on the job site, designed to handle the drilling and marking of mechanical, electrical, and plumbing penetrations. J-Bod is semi-autonomous and works directly from BIM, Building Information Modeling, data. The operator uses a remote control to position J-Bod in the target area, and then the robot handles the rest, drilling every hole within reach, marking others, and logging progress automatically. Accuracy is ensured through integration with the Hilti PLT 300 total station, giving tolerances down to the millimeter. Power comes from a rechargeable battery with up to 8 hours of operation per charge, and the integrated dust extraction system captures debris at the source, improving air quality and reducing cleanup. This machine is built to address two major challenges: the shortage of skilled labor and the need for consistent precision and repetitive work. By taking an overhead drilling task, J-Bot also reduces the risk of fatigue-related errors and improves worker safety. From high-rise office fit-outs to industrial facilities, Hilti's J-Bot streamlines workflows, maintains accuracy across hundreds of holes, and provides detailed reports for quality assurance. The result? Fewer reworks, faster completion, and safer job sites. It's not replacing skilled trades, it's giving them a robotic teammate to take on the repetitive, physically demanding work. The ASP NetOp system is designed to make working at height safer without slowing down the job. At first glance, it's just a net reinforced with a crosshair pattern, but the engineering behind it makes it a serious safety tool for roofers, solar panel installers, and maintenance crews. The standard NetOp kit weighs 14 kilograms or 30.9 pounds and packs into a backpack, meaning one person can carry it up a ladder without extra help. Once on site, setup takes as little as 5 minutes, even on uneven or sloped roof surfaces. The mesh is made from high tensile, synthetic fibers with UV and weather resistance, ensuring long service life under constant outdoor exposure. The crosshair pattern isn't just for strength. It also serves as a visual guide for positioning equipment, aligning panels, or spacing fixings during installation. In practice, NetOp acts as a portable fall arrest system and psychological safety buffer. Workers can operate closer to edges with confidence, which improves precision and speed while reducing fatigue caused by working in constant caution mode. Its modular anchor points are compatible with a variety of roof materials, including corrugated metal, tiles, and flat concrete. Maintenance crews value it for quick in and out jobs, while contractors use it as a lightweight safety net for multi-day projects without needing to haul bulky scaffolding. This combination of speed, portability, and safety makes the ASP NetOp a versatile choice for job sites where efficiency is as important as protection. Mycotile offers a radically different approach to sustainable construction, using the vegetative root structure of fungi, Mycelium, as a natural binder. Combined with agricultural waste such as rice husks, coffee husks, or sawdust, this organic composite can be molded into panels, blocks, and insulation products. Production is low impact, requiring 50% less water and 80% less energy than traditional mineral wool or polystyrene insulation. The chitin naturally found in mycelium provides enhanced fire resistance without chemical additives, while its dense network of fibers offers both thermal and acoustic insulation. Currently, Mycotile's flagship product line includes roof and wall insulation boards, but prototypes are in development for construction blocks, MDF, panel replacements, and furniture-grade sheets. These can be produced in custom molds, eliminating cutting waste and allowing for shapes and dimensions tailored to specific projects. Durability testing shows that when sealed, Mycelium-based boards resist moisture, pests, and mold, essential for long-term use in both interior and exterior applications. They're also fully biodegradable at the end of their life cycle, returning nutrients to the soil instead of contributing to landfill waste. Builders and designers see particular potential from Mycotile in green certified projects, where it can help meet LEED and BREEAM sustainability targets. Architects are also exploring its aesthetic appeal, with natural textures and color variations becoming part of the design language. By replacing energy-intensive, petrochemical-based building materials with a product literally grown from waste, Mycotile could play a key role in making regenerative construction mainstream. The London Power Tunnels 2 project is a massive £1.2 billion effort to reinforce the UK's electrical grid, requiring over 200 kilometres or 124 miles of high-voltage cable to be installed deep beneath the capital. leading contractor Balfour Beatty has deployed an AI-powered robotic inspection system to maintain precision during this critical infrastructure build. The robot travels along the tunnel's cable routes, using advanced sensors and vision systems to identify cable slack, improper alignment, and tension issues in real time. Accuracy is measured down to the millimeter, allowing teams to make immediate adjustments before the cables are fully fixed in place. Powered by onboard AI, the system doesn't just detect issues, it learns from them, improving its detection speed and reliability over time. It works seamlessly with existing installation crews, freeing skilled workers from repetitive inspection tasks and reducing the physical strain of operating in confined, underground environments. For safety, the robot is designed to operate in low light, low ventilation conditions, with dust-resistant housing and redundant communication links to the control station. Its continuous data logging also creates a digital record of every meter installed, invaluable for maintenance planning and regulatory compliance. By combining automation, machine learning, and precision engineering, Balfour Beatty is reducing installation errors, shortening project timelines, and ensuring the integrity of a power network that serves millions. In large-scale tunneling projects, where mistakes are costly and space is limited, this fusion of robotics and infrastructure is setting a new standard for underground construction. MSE wall coping panels are a precast reinforced concrete solution designed to finish and protect the tops of retaining walls, bridge parapets, and similar structures. Each coping panel arrives on-site custom fabricated to match project specifications, whether it's for railings, lighting, drainage systems, or complex curvature. Standard units measure 3 meters or 9.84 feet in length, meaning fewer pieces are needed, which reduces joint work and installation time. Since they are precast, these panels provide consistent quality and dimensional accuracy, advantages that are difficult to achieve with cast-in-place concrete. One of their main strengths is versatility. Non-standard shapes can be fabricated to fit unique design challenges, allowing engineers and architects to maintain both structural function and visual appeal. For bridge projects, the large panel size allows a crane to lift and set each section in one movement, saving hours of labor. The durability of these coping panels comes from high-grade reinforced concrete designed to withstand environmental stressors like freeze-thaw cycles, road salts, and heavy vibration from traffic. This makes them especially suitable for long-term infrastructure used for low maintenance is a priority. By reducing on-site formwork, curing time, and finishing work, MSE wall coping panels help accelerate project timelines while ensuring long-lasting results. A ground stabilizing system tough enough to secure a landfill, yet precise enough for erosion control on delicate slopes. Keep watching. The GeoWeb system by Presto is a three-dimensional cellular confinement technology used to stabilize soils, control erosion, and reinforce load-bearing surfaces. Each GeoWeb panel is made from high-density polyethylene, HDPE, which is resistant to chemicals, UV exposure, and extreme temperatures. A standard GeoWeb section can be expanded to create a honeycomb structure 30 centimeters or 11.8 inches deep, locking in soil, gravel, or concrete. This confinement increases load distribution, reducing rutting and erosion in areas such as roadways, embankments, and slopes. For landfill caps, the GeoWeb system can cover areas over 4,738 square meters, or 51,000 square feet, preventing soil movement while allowing vegetation to grow for additional stability. In slope applications, Presto's special load transfer system offers twice the tensile strength of convention geocells, ensuring the surface stays secure even under heavy runoff. When advanced erosion control is needed, GeoWeb can be combined with a geomembrane liner, reinforced concrete, and permeable aggregates to create a fully engineered barrier. This versatility makes it equally suitable for infrastructure, environmental restoration, and mining reclamation projects. The system's modular nature means installation is straightforward. Panels are delivered compact, expanded on-site, and secured with anchors before being filled. This not only reduces transport costs, but also speeds up deployment in remote areas. What was your favorite construction technology today? Keep watching for more.